This is a lesson on exponential functions, part 2. Now, the previous lesson on exponential functions concentrated on just the basic characteristics of that type of function. No real questions outside of knowledge-based ones attached to it. But this is going to be on some of the questions that you work with, things like domain and range, things like X and Y intercepts. So, to start, let's find the domain and range of the following. Y is equal to 2 to the x plus 1 minus 4. Now, before we really launch into this question, I would remind you, or have you pay attention to the transformations of this graph. This started off as y is equal to 2 to the x, and it's been translated 1 unit to the left and 4 units down. Now, if you were to graph that on your calculator, make sure you put brackets around the x plus 1, and you'd get something like this. Now, if it's a domain and range question, many people figure, well, I can just tell by inspection what's going on here, and no problem. Well, you might be able to, but it is kind of hard to tell what the range is going to be. The domain is never a problem with these because it's always all real numbers, but the range can be a problem because you have to visually try to figure out, well, how far down is this one going? So it is better to have a sense of what's actually going on with the equations, which is what I'm going to do. Now, if we, prior to looking at that graph, had a peek at it, but if we looked at the untransformed one, which is y is equal to 2 to the x. So before you moved it left and moved it down, you'd have the graph in black. And the range of this function is y greater than 0. That's by definition. You can work it out if you like. But exponential functions that have not been translated or in any way will have a range of y greater than 0. So the x-axis is a horizontal asymptote. And then when you do the transformation, 1 to the left and then 4 down, the new range is going to be y greater than negative 4. So if you look at the diagram, you get sort of a rough look at it. I dotted in y equal negative 4. The idea being that the graph has been moved down 4 units, so the horizontal asymptote has also moved down 4 units. The fact that the graph had been translated to the left has no meaning whatsoever with respect to the range. So all you do is pay attention to the transformation of 4 units down. That's going to tell you that the graph, the new range of the function, will be based on that. So this, I'll just make a little note, pay attention to vertical to translation. To find the range. That's really what it comes down to. And if you did use your calculator to graph it, you would really have to do a great job of tracing to figure out how far down it went. So there's no substitute for understanding the graph you're working with. Now the domain is simple. The domain will be all real numbers. It always is for exponential functions. You can substitute any number you want in for x. Now the second one, y is equal to 1/3 to the negative x plus 2, has 2 transformations. It has, because x has been replaced with negative x, this tells me that it's been reflected in the y-axis. There's also been a vertical translation of 2 units up. You might also pay attention to the fact that 1/3 as a base indicates that this will be appears to be a decreasing function. So I'm going to graph both. By both I mean 1/3 to the x, the untransformed one, which is in black, and then the one that has been reflected and then moved up to. And what's interesting is that when you do that reflection of the y-axis, I didn't show each step of it, but it changes to an increasing function by reflecting in the y-axis, so which is interesting. And then it is moved up 2 units. So don't think too hard about this question. If you need to get the range is going to be y is greater than 2. Here again, we care about the vertical translation. The horizontal asymptote used to be at y is equal to 0. It is now y is equal to 2. The domain, as before, is all real numbers. So these are exam type questions, just basically requiring you to know what you're doing. The next is the x and the y intercepts of the following. These also are test type questions, and I will remind you that you can always use your calculator to find x and y intercepts because you have a 0 key on your calculator. You also, to get the y-intercept, you can simply use the trace then the value key. Usually when you graph something, it'll always start you at the y-intercept anyways. But I'm going to do these algebraically. So I'm going to start with y is equal to 2 to the x plus 1 minus 4. We saw this graph earlier. And I'm going to graph it initially. I'm not going to use the graph to answer the question, although it's hard not to peek at it because it's a pretty simple, straightforward one. But what I'm more interested in is just to verify my algebraic solutions by inspection of the graph. Now, the y-intercept, never mind that little mark, the y-intercept is always found for any equation by setting x equal to 0. So you don't think too hard. You just go into the equation, replace x with 0. So therefore we get y is equal to 2 to the 0 plus 1 minus 4. So y is therefore equal to 2 to the 1 minus 4. Y is therefore equal to negative 2. So giving us 0, negative 2, which by inspection of the graph seems totally reasonable. The x-intercept might be a slightly greater challenge. So we set y equal to 0. So 0 is equal to 2 to the x plus 1 minus 4. Note that we have the unknown in the exponent, and that's telling me that this is a type 2 exponential equation. So that's why we spend the time getting good at those. Bring the 4 over, so 4 is equal to 2 to the x plus 1. And as with all type 2 exponential equations, we require a common base, if possible. Obviously, these ones have been cooked up to give us that common base, but 4 can be written as 2 to the exponent of 2. So when we drop the bases, we get 2 is equal to x plus 1. So x is equal to, subtract the 1 away, and we'll get x is 1. And that would mean that as an ordered pair, it's 1, 0, which matches what we see on the graph. Pretty routine one. Now the next one would be the same idea, but maybe a little bit more complicated. So here we have y is equal to 1/3 to the x plus 2 minus 3. I will also graph this one. You can too, and you could even use your calculator to get the answer for it, but I'm not going to bother. I'm going to do it algebraically and just peek over to see whether it looks right. The graphs can be a little misleading too. I mean, if you use the actual 0 key, then of course you're going to get it. But just by inspection, sometimes it's tough to tell exactly what's going on. So I replace x with equal to 0, and then we get y is equal to 1/3 to the 0 plus 2 minus 3. Y is therefore equal to 1/3 to the 2 minus 3. Y is equal to 1/9 minus 3. Now you could do this one very quickly. You could get a common denominator, or you could just reason your way through. I'm going to get a common denominator just for old time's sake of 9. That is 23. Try to get this one right. 27 over 9. So y is equal to negative 26 over 9. Now, if you want to write that as an ordered pair, you might prefer to put it as a mixed number. It doesn't really matter. It's going to be negative 2 and 8 over 9 in any case. And that appears to be right. It almost looks like it's negative 3, but just a tick upwards. And then the x-intercept, when we go after this one, here we set y is equal to 0, and it solves pretty nicely too. It will again be a type 2 exponential equation. The y is equal, or 0 is equal to 1/3 to the x plus 2 and then minus 3. Take the 3 over to the other side, and you'll get 3 is equal to 1/3 to the x plus 2. Get your common base. Now, your common base could either be 3 or it could be 1/3. I'll go with 3. I'll write that as 3 to the 1 is equal to 3 to the negative 1 raised to the x plus 2. So therefore, 3 to the 1 is equal to 3 to the negative x minus 2. Drop the bases now, and you'll get 1 is equal to negative x minus 2. Now you can solve this a number of ways. I'm going to bring the x over to the left side to make it positive, and then I'll subtract 1 away, and we'll get x is equal to negative 3. And by inspection of that graph, negative 3, 0 seems to be right. So, typical question. Now, in a lot of test-type questions, because everybody's so good at with their calculator these days, they often give you strictly algebraic ones, which require you to do them, in an algebraic way as opposed to a graphical way. So, if you got like this, y is equal to b to the x minus 2 minus 1 over b. There's no graph with this one because this is any base b. We don't even have a base for it. So you can't key it in. You have to do it algebraically using the same method and then hope for the best. So for your y-intercept, you as always set x is equal to 0. So this becomes y is equal to b to the 0 minus 2 minus 1 over b. And therefore y is equal to b to the negative 2 minus 1 over b. And with that negative exponent, you write that as a positive exponent, 1 over b squared minus 1 over b. And this takes us back to sort of simple rational expressions where you've got to get a common denominator. And that LCD is going to be b squared. And this one stays as is, but you have to multiply the second one by b, top and bottom. So that would give you 1 minus b over b squared. So your ordered pair for your y-intercept, whatever b is going to be 1 minus b over b squared. Now your x-intercept, you approach the way we always do. That is to say that you set y equal to 0 and you go along with it. So 0 is equal to b to the x minus 2 minus 1 over b. And this solves just as we have been doing before. Take the 1 over b to the other side. So 1 over b is equal to b to the x minus 2. Get yourself a base of b. So 1 over b becomes b to the negative 1, and that's equal to b to the x minus 2. Drop the bases b. Negative 1 is equal to x minus 2. Add 2 on, and x is equal to 1. So this one is going to have an x-intercept of 1, 0, interestingly. So that's the idea with these problems. X and y-intercept and domain and range. So the next lesson will be on applications. So we'll start looking at applications of exponential functions, and that will take us be a few days worth of work, and then we direct ourselves back into graphing for a little bit and logarithms. Thank you for your time.